Assalamu alaikum friends, welcome back to my channel Study with Shamal. So today we are going to study the chapter of chemistry which is electrolysis, and I have uploaded some parts of this chapter earlier, but I got a request from a subscriber. He wanted this chapter to be recorded collectively. So this is a collective and a very detailed video regarding electrolysis. I have written some of the basics of electrolysis. This is the definition of electrolysis, which is the breakdown of ionic compounds using electricity. And the ionic compounds must be aqueous or molten. It's very necessary that it should be aqueous or in molten state. This should be the state of the ionic compound. And what is an electrolyte? It is anything which conducts electricity when in aqueous or molten state. For example, molten NaCl or acids, etc. We have two types of electrolytes: weak electrolyte and strong electrolyte. Strong electrolyte, it dissociates completely, it completely ionizes, and the weak electrolyte, it partially ionizes. Okay, and small amount of current is passed through weak electrolyte, while a large amount of current is passed through is conducted through the strong electrolyte. And then we have the electrodes. Electrode, it's a solid which conducts electricity. For example, all metals and graphite. One thing to note, that why should the ionic compound be in aqueous or liquid state? So that it have free ions which can carry the current. Don't confuse the free ions with the free electrons. Now let's look at the electrolysis of molten compounds, molten ionic compounds. Basically, we have two compounds, molten ionic compounds and aqueous ionic compounds. The molten we denote with L, and the aqueous is denoted by AQ. So we will be discussing the molten ionic compounds firstly. So let's look at how the electrolysis of molten ionic compounds takes place. So here we will take example of molten NaCl. First thing first, identify. Rule number one. What are the rules for finding the electrolysis of molten substances? First rule, identify the ions. Secondly, the second rule will be that the anode, it will be attracting the anions, whereas the cathode, it will be attracting the cations. Okay, before the second rule, let's discuss what is an anode and what is a cathode. So anode and cathode. Anode is the electrode which is attached to the positive terminal of the battery, and this is attached to the negative terminal. Anode, it will attract anions and it will attract cations. Oxidation takes place here, while reduction takes place at the cathode. So this was about the anode and the cathode. Now let's look at the molten electrolysis of NaCl. So our first rule was to identify the ions, and I hope you all know that the metals, they have positive ion, while the non-metals, they are negative ions. So Na, it has a plus charge of +1 only, and chlorine, it has charge of -1, because it's in the group 1 and it's in the group 7. So now we have identified the ions, which is Na plus and Cl minus. Now look at the equation at anode and the equation at cathode. So at anode, we know that anions will be attracted, and the anion is chlorine. Anion is the negative ion. So chlorine, it will, oxidation means loss of electrons, so it is going to be losing electrons, and 2 electrons. Balance the equation, because here we'll be getting Cl2. We know that halogens exist in diatomic forms, so we will always be getting Cl2. Then at the cathode, cations are attracted, so Na is the cation, and reduction is going to take place. Reduction is the gain of electrons, so it is going to be gaining electrons and becoming Na, solid form, while this is in gas form. It was in molten form, and here it is then in solid form. So it was pretty easy. Now let's move towards the electrolysis of aqueous ionic compounds. Remember, in the molten ionic compounds, to the anode, remember these three things, and the rules. First, identify the ions, and then the rule for what will be going to be attracted to the anode and what is going to be attracted to the cathode. So this is very simple. Now let's move towards the aqueous ionic compound. Again, I will take the example of NaCl aqueous. First rule for finding aqueous ionic compound, the first rule, identify the ions. Second, the most concentrated will be attracted. At the anode, so attracted to the anode, and the least reactive will be attracted to the cathode. Okay, so now in aqueous compounds, we will be looking at the ions. The first rule, identification of the ions. So when aqueous term come, it means we will be having two more extra ions, which will be, the first will be Na and Cl, the ions which you already know, but two hidden ions. What are they? OH minus ion and H plus ion. These are the two hidden ions which are always in aqueous substances, and in a liquid we do not have H plus or OH minus ions. So now we have four ions. So the rule was that to the anode, anions are attracted, and to the cathode, cations are attracted. But here are four ions. So which anion and which cation is going to be attracted? So we have these rule for it. The most concentrated will be attracted to the anode, while the least reactive will be attracted to the cathode. So for this, for the question in which aqueous will be given, you will also be given about the dilute or concentrated. So firstly, let's do the electrolysis of dilute NaCl. So in dilute NaCl, the concentration of this will be greater compared to the concentration of this. So for the Ni, remember, when it's dilute, it means the concentration of OH is greater than the concentration of Cl. So OH minus, it will, we know at the anode oxidation takes place, so we will be having 4 electrons plus O2 plus H2O, and now balance it to H2O. It's balanced. And now for the cathode, at the cathode, cations will be attracted. So we will be looking at the reactivity series, and in the reactivity series, hydrogen is least reactive. It's less reactive than Na, so hydrogen is going to be this gaining electrons than Na. So it will gain 2 electrons to form H2. 2 hydrogen ions, it will gain 2 electrons to form H2 gas. And this is in aqueous form state. This is also in aqueous state. Here it's in gaseous state, and this is in liquid state. So it was also very easy. Just remember these rules, and you will be able to do the electrolysis of molten and aqueous substances very easily. Now, now let's do the concentrated NaCl, the electrolysis of concentrated NaCl. Concentrated. So when concentrated term is given, this means that the concentration of this will be higher than the concentration of OH. The anion given in the compound, for the ionic compound, it will be, the concentration of that anion will be higher than the concentration of OH. So we know that at the anion, the most concentrated will be attracted to the anode. So here in the concentrated, the concentration of Cl is higher, so Cl is going to be discharged at the anion. And for the cathode, again the same rule is applied. The least reactive, so hydrogen is least reactive in the reactivity series, and it's lower than Na. So hydrogen will gain electrons, 2H2 plus 2 electrons. It will become H2 in gaseous state, and here it's an aqueous. It's also in aqueous state, and while here it's in gaseous state. So what is the test for finding the hydrogen? Can you answer? It's okay if you don't know. I will tell you. For hydrogen, it um, it is extinguishes fire with a popping sound. No, sorry, it's not fire, it's lightning splint. So the test for hydrogen, it extinguishes lightning splint with a popping sound, and for the chlorine, it bleaches damp litmus. So it was the test for the chlorine. I hope you liked the video. If you have any other queries, you can ask me in the comment section. I will make a video on it too. So that's it for today. Bye bye.